Well, good afternoon, everyone. We're almost there, right? Almost to the end. Thank you for coming. My name is Jimmy Bogard. By the way, the description said .NET 5. That is a lie. This is .NET 8. If you were here for .NET 5 stuff, I'm sorry, that was 3 years ago. So yeah, we'll be focused on .NET 8 for all this stuff. You can find me on Twitter, I guess, at @jbogard, and I'll have some links to the actual code and slides at the very end, but they're all on my GitHub there. And you can follow me on my blog at jimmybogard.com. So my day job is a consultant. I mainly focus on modernization, application sort of stuff. I am not a security consultant, but I was asked to be one, and I like to get a paycheck. So I was like, sure, I'm a security person too. Yes, that sounds good. So this talk is about a project I was on in which they were introducing a lot of new technology, moving to microservices, all this sort of stuff. And this is a lot of stuff that I had to learn and implement as part of that project. I like things simple though. And so if I kind of go back to normal sort of web applications, we would just have something like this, right? Like a monolith or modular monolith, whatever. But it would just be there's a browser, there's the server, and then there's a database, and that's it. And we had the internet, which are people we don't trust, and then we had all of our stuff over here on the right. This is stuff we wanted to keep protected. And so we'd authenticate users so they could only see the data they're supposed to. They wouldn't see other people's data, that sort of thing. So for a lot of my career, we would just use cookie-based authentication, like forms login, cookies, and then just be this secure cookie going back and forth. I mean, there's a little bit to do on the server side in terms of we'd have to have a data protection certificate thing and make sure that no one tampered with the cookie. But it was very simple. I miss those days, honestly. But this customer decided to simplify things with microservices, which means that their picture was no longer simple of their applications and their systems. It was way more complicated, way more things going on. And so it looked something like this, in which we had a client that was a Angular SPA, single page application, that would talk to a backend for front end, and a backend for front end is really just a specialized API designed just for that one single client. And then this backend for front end would talk to n number of other APIs, microservices behind the scenes that had their own individual databases and whatnot. On top of this, we also had on the right on-premise clients. And so they were on the trusted network, but those applications would also need to talk to these very same APIs. And so this was the challenge that we were presented with of okay, before it was just cookie, everything was good. Now it's this. How do we secure all of these lines in this picture? So the first thing we needed to do is just for external users. So this is someone going to the public-facing website, logging in, whatever. So this client, as part of this effort, just picked not just, I'm sure there's steak and wine involved and golf courses and whatnot to go with Auth0. It's not a cheap option, but they decided to use Auth0 for their external identity provider. And there's a whole project involved in going to that. So it says, okay, that's great. That solves kind of that first part of going into the websites, authenticating, authorizing, and then at most really just talking to the backend for front end. The unanswered questions were, what do we do with the rest of it? So we needed to figure out, one, how should we approach internal Azure communication? So this is inside of Azure, Azure things talking to Azure things. So the backend for front end, that was an API, app service. Oh, no, it was Kubernetes, of course, microservice. It was a Kubernetes Docker image, something, whatever. But the point is, it was inside of Azure, something inside of Azure talking to another API that was deployed inside of Azure. The other thing we needed to figure out was on-prem communication. So there were existing legacy monolith applications that would also call our APIs were now deployed inside of Azure. And so we needed to secure those calls as well. Now, if we were trying to cut corners or we didn't know what we were doing, we could have just done nothing, right? We could have just relied on network security to say, you can't get to these resources unless you're inside this VNet or whatever. So then don't even, maybe just do transport security and nothing else. Just do SSL and then just call it a day. Just assume that if you can reach me, you're probably not a bad actor, right? Well, no. So they had some security consultants come in who recommended something called a zero trust model. And the idea here is that you never trust, always verify. And there's not a lot of documentation in terms of like what this actually means in real practice. It's like a lot of buzzwordy sort of stuff of like, yeah, okay, well, don't do the thing where you just assume because you made it this far, you must be good to go, right? And instead it's saying, well, we should always authenticate and authorize the originators for these calls along each step along the way. So the consultants like convinced management, CTO, like, yes, this is what we want to do. Do you want to do more security, right? No one ever really says less security, do they? It's always like, yeah, more. And so they said, okay, yes, it got approved. We're going to do the zero trust model. And then so I, as the architect and developer, was like, okay, great. How do you do this? But they were already walking out the door. So I was just given like, here's kind of a general direction of what we want to do. But in terms of implementing this in real systems and applications, that was just left up to us to figure it out. So we said, okay, never trust, always verify. Okay, so what does that mean? That means that we still want to authenticate and authorize users for every single line that we saw in that picture. So, okay, great. How? How should we authenticate and authorize those users? Well, one option we could have done is the users were already authenticated over here on the left. So they came into the browser through Auth0. They now have a JOT, right? Using the, auth code flow with PKCE, whatever. I don't know what any of that stands for, but that's what they were doing. And so we said, okay, could we, quote, just take that token and then flow it down, like just forward that token on to backend services? There's a number of reasons why you should not do that. One of the big things we noticed or we saw as part of like trying to do that was the scopes that you are authorized for as part of calling this API may not be the scopes that you want to authorize for these backend APIs. You may not want to allow users to bypass, somehow, let's say like the network security screwed up, whatever. We don't want users to bypass this very important backend for front-end layer to go through and directly call microservices in the backend. This particular project involved health data, and there's a ton of laws, like probably in this country as well, that govern like who can see what data, and they need to have like specific agreements. So if it's a spouse or dependent, like you have to have explicit opt-in agreements to be able to see that protected health data. So like, well, the rules for all of that weren't like necessarily being applied on every single internal service. We only applied those at the edges because it was so complex. So if they called from the client directly to our services, they could bypass a lot of those protections we had in place for the data. So if I just, quote, just flow the token, that would imply that the user, if they could access this API in the back end over here, they could access like the microservice directly, and I wouldn't even know. The token looked exactly the same. I wouldn't know if they were coming, I guess, from like refer URL or like IP addresses, but this is not something that we wanted to allow to happen. The other problem is that on the right here, these on-prem systems, those were like web forms apps from like 2006 or something. So they were still just using cookie auth. And so there was no token. So like, well, do we like, depending on where you're coming from, I'll allow you to use the token, or, oh, wait, you're coming from over here, so I'll go look for the cookie instead. And it would greatly complicate the security picture of these microservices behind the scenes if I would just be like, I will support any like edge authentication and authorization strategies there. So we don't want to do that either. So like just flowing, like quote, just flowing the user token was just not going to work on a number of different reasons or a number of different levels. So we said, great. So we can't use the kind of edge authentication authorization, but we're inside of Azure. Why don't we use the capabilities that Azure provides? And so the solution for us to use, now it's called Intra ID. It was called Azure AD. I should have changed this. So yeah, the solution was use Microsoft's identity provider, which is Azure AD, or now Intra ID. None of the packages or libraries have changed the name, and they won't change the name. So you'll still see like AD, identity, that sort of thing in all the packages and libraries. It's a pure marketing term on the, the CMSs got changed, but nothing else behind the scenes. Okay, so yeah, like, we're inside of Azure. Azure has these capabilities, so let's use that. But that still poses the question of like, okay, we're going to use this identity provider. how specifically are we going to authenticate and authorize these calls between these different services and on-prem applications? So yeah, that was the next question, is how do we authenticate these callers? I want to say users because they're not always users. We didn't just have end people, humans, that were originating these calls. We also had things like scheduled tasks, cron jobs, messaging endpoints, things that did not have any kind of user information whatsoever. Those still had to make those calls as well. Luckily, Microsoft does have pretty good documentation about the different kinds of flows for OAuth 2. So that's the next thing. It was like, we're going to use the standard, right? We're not going to make up our own authentication flow for some of these things. I mean, I've seen that done sometimes where people will make up their own headers and do their own flows. Well, we want to, as much as possible, stick to standards because that lets us use packages and libraries out of the box without having to do a ton of customization. So the Azure documentation describes these different possible OAuth flows. These flows will apply to different scenarios and also different kinds of audiences. And this is where it is kind of specific to the identity provider. Auth0, of course, does have its own way of doing all these different things. So we could have picked them if we wanted to, but there are two problems with that. One was the migration to Auth0 was running a year behind, and we weren't even sure if it was ever going to happen because identity migration is not about identity. It's more like an integration nightmare. So we don't want to, hitch our wag. No, anyway, we didn't want to pick something that we didn't think was actually going to go live. So we said, okay, we'll go with Azure. But these are all these standard flows here. So we just went by one by one. Which one of these is most appropriate for our scenarios at hand? The first one is single page app. Well, there is a single page app, right? This Angular SPA. However, that authentication is going to be using Auth0, using this flow, the auth code flow with PKCE. And so we weren't going to change that, right? They're already going to Auth0. The possibilities for us to use intra ID, I think what's called Azure B2C or something like that. I've not yet heard a good story about that product, and it was out of scope anyway. This is just the kind of behind the scenes communication. So that was out. Web app, same thing. This is not a web app. These are APIs to APIs. What about the next one? Web app that calls web APIs. That's kind of what it is, right? But it's an API that calls APIs, so it's slightly different. Desktop app that calls web APIs, no, that's not us. Mobile app, there was a mobile app, but that wasn't us either. This one's interesting though. Web API that calls web APIs. That's what the picture was, right? The backend for front end is an API that calls other APIs. So that one we could use the on behalf of flow. And the final one is just kind of the catch-all, just like the last one that you could use is a daemon app that calls web APIs. So ours weren't all daemon apps, but the general gist of it is I don't have a passable, flowable user identity token from the calling app to us. And so that kind of gets lumped into the bottom of a daemon app that calls web APIs. And that would use the client credentials flow. So ideally, we could use the web API that calls web APIs, but the problem is over on the right, who the audience can be for this. An on behalf token will basically, now that I have a valid token, I will acquire a new token on behalf of this user, but this time I'm going to not necessarily just get all the same scopes that I had before. I will say that, okay, based on this token and then who this caller is, I can then get authorized for these other scopes to then make further backend calls. But this only works for the tokens, incoming tokens, if those tokens are also Azure AD intra ID tokens. But we're not that, right? We're both Auth0 sometimes, and then other times it's like cookie apps, and other times it's these client, just headless applications. And so really that just came down to this one. The only one we had any kind of valid use case for was client credentials to be able to authenticate and authorize all these different calls for the backend services. Okay, so we have a direction in terms of the flow we want to use. The next thing we needed to figure out was how do we authorize those callers? So we don't have that initial token coming in, so we don't necessarily who the original user was. So what should we use for authorization? It's just because you have a valid token, I don't look at anything else. If you got a valid token from this tenant, then that's good enough. Well, again, because we were dealing with protected health data, we wanted to apply a little bit more scrutiny to authorize these incoming calls. Now, this is, again, specific to our needs there. So you do have quite a few options in terms of how you design your authorization schemes. But one of the kickers we have here is that even though it's called OAuth, the auth is not authorization. So it's not like, okay, I have these specific kind of permissions and rules for looking at specific set of data. It's completely up to you and your application to decide what makes sense in terms of authorizing incoming calls. So the Intra ID product has two main options of how you can authorize these kinds of calls. The first one is known as access control list, or ACLs. So the server application will check the claim, so it'll check the issuer, like is it coming from the right place, checks the audience, that sort of thing, and then just does custom logic. So it's called access control list, but it's like, there's nothing built into Intra ID to do access control lists. It's just like, well, we won't give you any additional token or any additional claims. It's completely up to your application to just enforce its own rules on how it wants to authorize stuff. The one that is built into Intra ID are the second one, which is known as application permissions. This is where like every identity provider has its own kind of way of doing this. So Auth0 has its way of doing kind of role-based authorization checks, or RBAC. They all do. They all have some custom way of doing so. So this is now exiting the realm of OAuth flows, and it's more just like I'm configuring identities to issue claims that have this information in them, but then it's really up to my server then to to authorize against these different permissions or roles. So in this one, we define custom roles inside of Intra ID. We assign those roles to the server principals. So these are like the server application that's making these calls. And then the token, when I say I am client A, wanting a token for server B, I ask Intra ID for that token, I authenticate against this, and then the token I get back will include those roles as a claim inside the token. So it's similar to just kind of random claims, but this time they're going to come over in a special roles claim that will include all the roles assigned for that specific server resource. Then on the server side, when I receive those calls, I will then authorize against those roles. What I did was I built a very simplified application. So I know I had like microservices and all this sort of junk, but I could basically boil down to a couple main scenarios. The server here will represent my backend from front end. No, I'm sorry. The server here will be represented as my backend microservice. So this is the API that is calling databases with its own data, that sort of thing. Then I have two clients. One is a client that is completely inside of Azure, deployed to Azure, either Kubernetes or Azure Container App or Azure App Service, whatever. It is a completely inside of Azure client. Then I also have an external client. This external client represents on-prem system or just anything else that is not inside the Azure ecosystem. Okay, so the final piece of the puzzle was defining what these application permissions / roles should be. And this is something that you define inside of Azure completely. You just type in strings and you define the roles, and then your server will then authorize those roles. But we still have to design what those application permissions should be. Now, in some of my more complex, like management applications, backend admin system sort of things, we have like custom rolled system to do this, right? You might have a system in your application that has like a table with, like you have an enum that is all the permissions. Then you have a table that is for the roles and permissions, or groups and permissions. So you assign permissions for actions and activities. You assign those to individual roles or groups. And then you assign users to those groups. A similar kind of construct is inside of Azure. And so when I'm going through this, I'm picturing like, well, if I was building a completely bespoke permission system, this is probably what I would come up with. But we have to define what are those permissions that my application is going to authorize individual users or services can perform. So in this dummy application, of course, like every API and SPA sort of demo here, it's just a to-do API. And so this to-do API exposes just the sort of normal CRUD operations for to-do items. So you can get all the to-do items, get one to-do item, you can update a to-do item, you can post and create a new to-do item, or you can delete a to-do item. So all the kind of things you can do with these to-do items. So a very naive implementation for roles would be to map each of those kinds of activities to a specific action the user is performing. So they can read, update, create, and delete. Now, when I'm designing permissions for like real systems, like user-managed systems where users are assigning, this is something that we often map to like pages in the application, or like groups of actions they can perform, maybe menu structures, things like that, to say, how do I want to design the permission structure for the different things the user can perform? And there can be there's kind of a tug and balance between making things super specific, like I have here, and then it can be very super customized and exact about exact actions user can perform, or I can go the other direction and be very generic and do something like role-based authorization is user admin, and that gets you to be all these sorts of things. So this is when we struck a bit of a balance and said, basically there's read and write operations. We even went one further, so we also included any API endpoint that included protected health information. We would have like an additional permission that says, only the applications that we know can perform the extra checks will be able to get this permission to perform like protected health sort of things. So this is something that is a design activity to figure out what makes sense in terms of the permissions here. As far as Azure concerned though, these are just strings. The strings that get stored somewhere and get assigned to things. There's no knowledge of any of these sort of things, but it does use the exact same mechanism that all the other RBAC controls inside of Azure do. So if you've ever had to I don't have access to Key Vault. Someone needs to assign me to a group or assign a permission to me. This is using the exact same structures and capabilities underneath the covers, except it's now customized and I can define it for myself. What's nice about that is that it also means that all the libraries you're using for Azure resources can also be used to access your applications and your APIs and your resources. So we don't have to bring in a whole bunch of new junk to be able to do this. So the same library I'm using to communicate with Key Vault, with Azure SQL or whatever, those same libraries are what I can use to now talk to my own APIs because they're authenticated and authorized and protected with Azure Intra ID as well. All right, that's enough slides. Let's switch over now to our demo. Like I mentioned before, let's see, there was a hotkey for this. Let's see if it works. It did not. That's cool. So we're going to go to, let me mirror my screen. Wait, it is mirrored. Oh, I'm already there. Brilliant. Okay, so this is my simplified dummy application where I've got a client, Azure client, an external client, and the Azure server. And then the one extra piece I've added here is infrastructure. To make my life a little bit easier, I'm using this tool called Pulumi. This is not a Pulumi talk. I will be showing a lot of Pulumi just because clicking around the portal for all this Intra ID stuff is maddening. It's not obvious how these different pieces connect together. Pulumi, though, lets me define cloud resources with code. And then in the code, you can much more easily see how the different components are connected together. So that's the only reason I'm using this is I also want to learn Pulumi. So this was the forcing function for that. That's not the important part. It's just an easier way for me to get my resources up and running and to show how it's connected together. Okay, so the first thing we're going to need to do is build out our server. So my Azure server, this is just a ASP.NET Core Web API application running .NET 8, and I have my two APIs I'm exposing. One is not secured, this weather controller. There's no authorization here, so anyone can call this. And then the to-do items is actually secured. Okay. So before I really go anywhere, I have to create some Azure resources that I can then configure inside of this application. So let's go over to my Pulumi stuff and walk through that. So in my stack here, the first thing I'll be showing is my server. So again, this is Pulumi, so it's just an object that it gets instantiated and creates all the stuff. So the first thing I need is my app service. So this application is going to be deployed as that should be 8. Oops. There's an Azure App Service. There's nothing really interesting here. This is just a single Azure App Service that is running over here. Yes. Let me refresh it because this is free, and so it's probably like not warmed up anymore. Yeah. Oh, it is. Wow. Okay. Yeah. So this is my application deployed into an Azure App Service in my Azure registration. So the next thing I need to do is I need to create some Azure Intra ID resources that can then be used to secure this application. And this is the part that is different for every single identity provider. So like Auth0 has its way of doing things, Okta has its way of doing things, but they basically just means of setting up resources to enable OAuth 2 flows. So inside of Intra ID, I create what's known as a server application. A server application is a way of identifying I am something that can be secured with Intra ID. And it creates this, I imagine there's somewhere in Azure, there's a table called TBL principles. And then there's an offshoot that's TBL application. And this is a thing that it can be used to assign permissions and to authorize against. All right, so I create this application. And so if I go over to Intra ID, what does this look like? Here is, Intra ID is right here. This results in an app registration. This application, and by the way, this is called like 3 different things inside of Intra as well. It's really annoying. So the actual Azure SDK resource is called an application, but in the UI, it's also called an app registration. Whatever. So what does this create for me? It creates this app registration object. And the important bit here is that it creates a, it gives me this application/client ID. This will be important whenever we're doing OAuth flows. When I say I want to acquire a token for this thing is represented by that ID. So I don't just acquire a token in a generic term or generic sense. If I'm resource A wanting to acquire a token for resource B, I ask Azure to say, give me a token for that specific resource because I may have permissions that are different between different resources. Okay, so this is important here. So we need to, in our Azure server, if I'm a web API that needs to authenticate and authorize against Azure AD, what we need to do is bring in the Microsoft Identity Web package. So this is the package you use if you are a server API that needs to authenticate and authorize against Azure AD. This makes it a lot easier. You don't have to use this, right? There are libraries inside of .NET or ASP.NET Core to do just generic OAuth flows, but this one makes it like 8,000 times easier, so we're going to use that. How does it make it easier? Well, let's go to our setup here in the program CS. I'll get to Swagger in a bit here. So here, we are going to call builder.services.add, the longest extension method name I've seen so far, add Microsoft Identity Web API authentication, passing in the configuration there. We'll get to this other weird junk here in a little bit when we talk about roles, but this is the important bit. This will do the authentication and authorization or all the services to do so. And then down here, when I do use authentication and use authorization, like that'll do then the real get the authorization provider, check the token against the claims and all that sort of stuff. The configuration I need, though, as part of this, is in my app settings. And so I need to give it the Azure AD configuration here. So this includes the instance. It's probably not this one for you. It's probably like a real tenant, up in Azure. But this is my personal Azure credit, so it's just going to be that one. The tenant ID, which is going to be constant for the entire tenant of Azure AD or Intra ID. And this client ID is important because this client is this GUID right here. So F2BB blah, 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 blah. This little guy here is what I stick in right here. It's a little confusing because you're like, what is it? Is the application ID or is the client ID? Or is it both? Well, it's the application ID, but it hasn't quite caught up to renaming all these things here, of renaming client applications. So it's going to be a little confusing sometimes, the naming, but this is where we are. Okay, so when I run this, run. I also have Swagger configured. So over here in my Swagger configuration, over here, we will also include the OAuth information. So we'll say, oh yeah, we're doing the OAuth auth code flow, and this is the information and whatever. And Swagger UI, the same kind of thing of like, we want to enable the OAuth in the testing or in the Swagger UI, so that I, as a developer that wants to test this, I can. So here, right, we want this little green button to show up over here. There we go. And I want that to do something. Okay, but there's a problem though, because like when I click authorize and I say I am a, I'm an Intro ID tenant, well, now it's me as a human being trying to get a token. I'm now back to like, well, I'm a user acquiring a token. I'm not like a daemon application using client credentials. Technically, you can configure Swagger to use client credentials, but like that means the client secret needs to be in the browser somehow. So if you try that, if you try to authorize and get a token from Intra ID from a browser using client credentials, it will not let you. Because it says, wait a second, you shouldn't be using a secret in a browser. Like that's absolutely not what browsers are not secure pieces of code. You should not be doing that. So actually we'll refuse you. We actually tried that at first. We said, we'll have a dev client ID and secret, and then we'll put that in there, and then Intra is like, you can't do that. So that means that I actually need to enable the auth code flow for this API so that I can test it with the browser. Now in upper environments, we do turn this off, but for local development, I do want this turned on. So back over in my server, we have to do some additional junk to be able to turn those different pieces on. Actually, before that, let's go into roles, because we also want to authorize against specific roles. So in order to authorize roles, I have to define those roles as part of my server application, because I'll be using Intra ID to assign roles to principals. So here I create some well-known role IDs, and this is just a way for you to reference those role IDs in other places. And then here, as part of my definition of the application, I say, okay, your app roles are two. You've got one for todo.read and one for todo.write. I also tell it who can be assigned these kinds of roles. Like I say, users can be assigned these roles, and applications can be assigned these roles as well. Now, once I have those roles defined, if I go over to my this is the app registration. If I go over to app roles, there we have todo.read and todo.write showing up there. I could create it here, but we should be using infrastructure as code, right? So we should be like actually using, like Terraform or Bicep or whatever. I could do it through the UI, but then it's not very repeatable, and I'll definitely forget something as I'm going through all this. Okay, so I've defined the roles as part of my application. In my actual code itself, if I go look at the to-do items controller, the first thing you'll see is that I'm authorizing here, right? So you have to be an authorized user. You have to have a valid token. And in each of my API endpoints I expose these controller actions, I will say authorize roles equals the role I want to authorize against. So this authorize attribute is not aware of Intra ID. It doesn't know about this. It just knows you have a principal, and there's a principal or user that has user.isInRole, and it calls that thing to say, is the user in this role? And if the user is in this role, then it returns true. If not, it returns false. But something needs to populate those roles from the incoming token. So that piece is back over here. This janky looking thing that says, there we go, where I say, clear the default inbound claim map. And the reason why it's doing this is like, there's two versions of Intra ID tokens, and one has this like really weird like SOAP looking URN that defines the different claims. And so these two pieces just say, hey, don't like try to map to what you think it should be mapped to in these weird like URNs for claim types. Just don't do anything. Like as the claims come in, just leave them alone. Don't touch them, please. If you don't do this, it won't properly map the roles claim to a roles claim and the identity, and then isInRole won't work. And this took me like a week to figure out that this was very important set of code to make this role-based authorization work. But once this is hooked up though, then my application code has no knowledge or understanding of Enter ID at all. This is just standard role-based authorization in my application code. And that's what I want as a developer. I don't want to have to be calling into specific SDKs or APIs, just authorize a specific role. So there's to-do.read and to-do.write. Okay, so I've got the incoming roles mapped. I've got them authorized. But when I F5, I need to do this last piece of I as a user need to one, have the ability to do this flow of auth code with PKCE. And the second thing is I need to make sure that when I ask for a token for this resource, I want my user to also be assigned those roles as well. So that I, as a developer developing locally, the token contains those roles and they can pass them through without any problems. So those pieces over here, I exposed out the role IDs. Then the next thing I need to do is create an API definition. And the API definition is how you tell Enter ID that like I am now going to support these kinds of OAuth flows. So I do a couple things. One is say that you give the 2.0 version of the token, because tokens, the JOTs are contracts, right? Those can change. And so this is just saying I want this specific version of the token coming through. And then I'm going to say I'm going to expose an OAuth permission scope, which is, yes. So I'm going to expose an OAuth permission scope so that when I ask for a token, it will allow that scope to go through. And down here, this is where I can expose the OAuth auth code flow. So I will say that you are a single page application and your redirect URI is going to be like the localhost one. And you've probably had to do this with, if anyone here has used like, even using OAuth or Okta, like you have to set these kinds of things up in order to enable local development to authenticate against some other identity provider over there. I have to enable, these are the allowable redirect URIs for this resource. This one is the actual, the real application out there when it's deployed. And this one is the like localhost. This is my local debugging one. Okay, so now that I've got the OAuth flow set up, in order for me to assign permissions to this and have permissions assigned to it, I need to graduate my app registration to what's known as a principal or a service principal. So I'm going to create a server service principal so that my application can both run as that service principal and there's something I can be assigned against. And I tell it, you are now a service principal with this application ID. And what this does is over in my, yes, right here, this will light up this managed application and application ID over here. So having these things lit up means now I can assign, this thing is now a resource that can be, that you can now assign permissions to and be authorized against. Yes. Okay, so this last piece is saying, okay, when I am running this application using auth code with PKC, those application clients will be something different. And so there are some very magical client IDs that you need to add. And so this is what I'm adding here is like, there's a quote, well-known, so if you Google that GUID, you'll have like a ton of Stack Overflow results that say, hey, you need to put this in here. Because when Visual Studio asks for a token, it's different than like something else asking for a token. So I need to make sure that this like well-known Visual Studio one, or there's like several of these, like there's one for Visual Studio Code. There's one for Visual Studio with this MSA stuff. There's also one for the Azure CLI and PowerShell. So like you'll just need to, if you're trying to call your API and authenticate against your resource, you'll have to then add those as pre-authorized, well-known clients that can call for that. Okay, so the last thing I want to do is I, as my Enter ID user, Jimmy, myself, I want to be granted those roles whenever I ask for a token for this resource. So this is something that is explicit you have to opt in for. So back over on my stack here, when I create my Azure resources, oh no, not that one. Oh, yes, not that one. My Azure AD resources, that's the one. Oops. I get my user principal name from configuration, which is just my, like the weird on Microsoft email thing. And then I'm going to create an Azure AD group. It'll be inter ID eventually, but like I said, it has not filtered down to all these APIs. And then I'm going to assign my group, assign my user to that group. And the reason why I'm doing this is application permissions inside inter ID can be assigned to users, groups of users, service principals, and managed identities. So those four things, like other applications and service managed identities as well. I don't want to have to, like, every time a new team member comes on board, that have to go like explicitly give them their permissions. Instead, what we'll do is like, we already have like well-known AD groups for developers. So I want to assign the permissions to that group, and then anyone that joins that group then gets these permissions. So back over here, we can see that if I go over to app roles, well, let me get to, no, not through here. I have to go back up to the managed application, enterprise application. And then when we see the roles, users and groups, this is the one I never, oh, here we go. So that tells me that these are the different principals that have been assigned different roles. So here I have a Azure AD group that has been assigned the to-do.read and to-do.write. And how do those get assigned? Well, because Pulumi is an object-oriented language, over in my server object, I will have a method that says, you can assign read, which gives the ID of the role, the ID of the principal, and the ID of the server rinse. So there's like some table somewhere that's like, there's a permission, there's a the thing that's being assigned, and then the assignee, the assigner. Yes, so I need those three pieces of information to connect the role, the application, and the principal resource that is getting assigned that permission. So I created two methods, assign read and assign write. And for local dev, I have a method called assign roles that is going to assign the read and write roles for this based on the local dev group name and the local dev group object ID, which is, again, a very important thing you have to keep track of here. But because I'm in Pulumi, I can connect these pieces much more easily than copying and pasting GUIDs everywhere. So back over here in my stack, I will say server.assign roles to the Azure AD resources. And that's going to perform that operation to connect those pieces that eventually results in this table here. Okay, so let's go back over here to our server. Now with all this in place, I should be able to authorize, click this button, get this special scope, which is only there to support this specific flow. I've already authenticated, so it's already done this. I close, and now I can call this API with that authorization. So I say try it out, execute. And it will work right now. What? Oh, I had a breakpoint set. Yeah, so I made it inside there. And if I go look at the user claims view, let me zoom in here. Yes. So here we have the audience, the audience, issuer, exp, IO, ASP, acre. And then down here, you can see roles to-do.read and to-do.write. If I look at the jots, let's go hit go. It did return the things right here. So we got the API stuff back. And then let's go look at this token. Oh, go away. No. If I get this token, I'll go load it up in a jot viewer. Jot.ms. Yes. And let me get rid of the other junk. And do I need more stuff removed? There we go. Whew. And sure enough, there's my roles claim. Now, if you use like other OAuth flows, you'll see like just different claims coming in with different scopes. So we're not using those scope things, we're using the roles claim. So it comes in as an array of these are the roles that my user has been assigned to that server resource. These two individual roles. There's a question in the back, yes? So the question is like, it basically comes down to the design of your permissions. That is 100% a like design exercise about what they should be for your system. And I can't answer that. It is entirely dependent upon what things you're doing and how much granularity do you want between the different operations in your application. You may just say like all, like if you can acquire my token, then I don't care, just everything. For this one, we did have at least like 3 or 4 levels of different kinds of data we wanted to protect. And so we had like those different levels in our permissions as well. So these are, again, very different than like application permissions that I would assign to like an application. These are things that are service-to-service communication inside of Azure. All right, so great. So I can actually run and test my application, huzzah. The next thing we want to look at is the other actual calling client applications. So let me go and stop this. And then that's all we needed to do for the server. The server's done. It's now authorizing calls against intra ID, authorizing against that client ID. So let's next look at the external client. So the external client is just represented as a console application. So this is just a console worker application. So it's like imagine a daemon application or on-prem, whatever, but it's outside of Azure. So if I'm outside of Azure and I'm trying to acquire a token for something using Azure Intra ID, then I'm going to be using this package, the Microsoft.identity.client library. If you're also trying to get tokens for any kind of Azure resource outside of Azure, that's the package you're going to be using as well. The next package I'll show just uses this underneath the covers, but this lets me easily acquire tokens for Azure resources. So the first thing I have to do is configure my Azure resources to identify this individual external client. So over here in my infrastructure, if I go to my external clients, again, I'm creating an app registration. So this is like an identifiable principal that wants to acquire a token. And this time, instead of me doing a like OAuth flow with auth code PKCE, instead I'm going to be using secrets. So in this case, I'm going to be creating an application password to use for client credentials flow. So you need a client ID and a client secret. This is going to be my client secret. And then finally, I hook this up to a managed service principal. Here we go. That says now I'm a thing that can be they can both assign permissions to and permissions for. That's this piece. So over in my here, so you won't see, here we go. This is my external client app registration. So this app registration includes a secret. Now you don't have to use secrets, you can use certificates as well. I think we wound up using certificates in some cases and secrets in others, just kind of depending on who you were. But this now creates this client secret with this value, whatever. So when I want to acquire a token, I need to include that secret. So how do I acquire that token? So this application, again, it's a daemon application, the client application. We need to assign the roles. So in this external client, what I've done is my server object assigns client group roles, but I'm going to only allow read. Just to highlight, like, so there's some clients that have different permissions. So its token it gets back will only include the to-do.read role value. All right, so over here in my external clients, so I'm going to be using an HTTP client to make these API calls to my server. So my client secrets, I'm going to be using user secrets. Like you'd probably be using, I don't know what you'd be using, but so we want to make sure that secret is secret. So that's where it's going to be getting the secret from, so that takes the secret from user secrets and adds it to configuration. And then I've got a worker. So a worker that will be calling the API. It will be saying, okay, I want to get a to-do items client. So this is using the typed HTTP clients pattern here. And then I'll be calling get async just to get a single to-do item. And then then it'll try to put it. So it'll try to make a write. It does not have authorization to make that write. So we want to make sure that we get a 403 here, unauthorized. So how does this HTTP client get set up? I wanted to make sure that my users, my developers, didn't have to like manually add bearer tokens everywhere and acquire the whatever. So what I've done is configured an HTTP client to add some middleware to automatically acquire that token. So I'm going to create first this confidential client application. So this is from the Microsoft Identity Clients library. And this is the piece of code that will allow me to acquire a token for resources. So it says, I'm going to acquire a token for this client ID. This client ID is this now. And then I'm going to be acquiring a token for this other server application. So that is the ID of the server that I'm going to be calling. So we set up some configuration options. So I say these different options objects that are going to be the client ID, client secret, as well as the URLs. Those are coming from there. And then we're going to be setting up our middleware. So I'm going to be adding these auth handlers. And these auth handlers are the things that are actually going to get the token. So this is now HTTP client middleware, these delegating handlers. And then it depends on an confidential client application that comes from Microsoft Identity Client. And that is the object I can use to acquire tokens in my server code. So here, I'm going to say, I want to get this magical scope of the application ID. So that's the thing, the resource on the other side I want to acquire the token for. It's going to acquire a token for the clients, and then add that value as a bearer token out the door. So let me run the server, and I'll run the client. Okay, server's up and running. Now let's go ahead and start up the client. Okay, so it looks like it succeeded the first time, and then the second time it failed because 403, right? So when it tried to do the write, it failed because I don't have access. And I just logged the token out here. So let's go ahead and go to jot.ms again. Jot.ms. And we can see here that my roles now only include read, because I've only assigned that role to this external client resource. And like the other person asked, like this is the part is like really up to you about how you like to define these different ones. Auth0 and Okta have a similar kind of definition where you can do your own role-based authorization controls. And so that's what I'm doing here is I am defining my own RBAC for my applications. And so it's really up to you what you decide makes sense for those roles. The audience, this is the server it's calling. And then I don't remember what all these, the subject, which is me, is that other ID there. The other IDs mean stuff as well, but I forget. All right, so that is client ID, client secrets, the client credentials flow for an external client outside of Azure. But it turns out if I'm inside of Azure acquiring these tokens, there's a much easier way of doing so where you don't have to manage all these different secrets. Now, of course, we can use certificates, but those also expire as well. What we can do in Azure is use a tool or a resource available to us known as managed identities. So managed identities are something that I've used for quite a long time in order to make sure that like not anyone can access my database and key vault. I create this managed identity thing, and then my app service, Azure Container App, whatever, will then use those managed identities to authorize against SQL, key vault, whatever. But I can also use those same managed identities to assign roles or for the intra ID, like these custom role-based authorizations. So what does that look like? Well, first we need to set up all the Azure resources, and that's going to be in this client here. So this client is going to be running inside of Azure, so it's going to be running as an Azure app service. I just picked one that was easy, but it's going to be using an app service. Most of it is pretty normal sort of setup, like, okay, that's HPS only enabled, .NET Azure clients. But the important thing is that I need to say, okay, Azure Web App, you're going to be running under a specific managed identity. In this case, I'm creating a user assigned identity, which is like identity I make up. But you don't have to do that. It could be any managed identity. So I say I want to create a user assigned identity that is now defined inside of intra ID, and I'm going to assign this managed identity to this Azure App Service. So down here, I say, okay, you web app are going to have this identity. It's going to be a user assigned. The other one is like a system assigned underscore user assigned. I guess you could do both or none. Default is none, of course. You don't always run under a managed identity, but I'm going to tell it you're going to run as this managed identity. So when I look at my app service in Azure, I can look at this client here. And when I go over and look at the identity, we can see that oh God, go away. No. We can see that it's running under a user assigned identity, and this is the name of that user assigned identity. I can go click this, and now I'm in intra ID land. This is this managed identity, and this managed identity is going to have this very important client ID. So I need to assign that client ID, those permissions for that server resource. I'll do that, again, back here in my Pulumi code. So over in my server, I define a method for assign roles to the client now. The client is going to be assigned read and write, both of those. So when my client running inside of Azure wants to acquire these tokens, it will acquire these tokens as this managed identity and will be assigned those two individual roles. So the client now needs to be configured to set this up. And the way I decided to set this up is this Azure client is still .NET 8, but it's also a web application. This is my BFF. So pretend like this is using a real authentication and authorization for its incoming calls, but I didn't do that. I just turned it all off. So I just merely exposed out APIs that don't do any kind of authentication or authorization and just calls the underlying client directly. So my to-do items, no authentication or authorization. This is just to say I can acquire a token as a managed identity. So really I would have something, but I don't in this one. So yeah, it's no authentication authorization. But again, I want to configure my HTTP clients to automatically acquire those tokens. This is going to be another library from Microsoft, because if you are now using managed identities to acquire tokens, now you graduate up from Microsoft Identity Client to now Azure.identity, this one right here. You probably have already used this if you're using managed identities to talk to Azure SQL, Key Vault, whatever. These all use Azure Identity underneath the covers. So I'm going to do a very similar kind of setup here in my HTTP client, where I'm going to configure a token acquirer. Oh wait, nope, nothing there. In which I'm going to now create something that can acquire a token. Well, this token acquirer is known as a token credential. So this is one where I use this default Azure credential, which is actually a chain of responsibility. So it's a composite of multiple different credential providers. It will look at your Visual Studio subscription. It will look at your Azure CLI for CLI and Azure CLI, or it can look at VS Code credential, or if you're running in managed identity, it'll use that credential instead. So it's like I can use all these different kind of credential providers here. We'll get to this auth. Yeah, let's look at this auth handler. So this auth handler is another middleware, but this time instead of using the client application thingy, it's using a token credential. So I inject a token credential into here, and then I do a very similar kind of like setting up the scope I'm looking for. So I'm looking for the application ID of the server object. So that when I get this token, it's now going to be getting the token for that specific server application against my managed identity or my user if I'm running inside Visual Studio. So with this in place, now in my configuration here, I will give my HTTP clients, strongly type HTTP clients, this middleware to execute as part of every single request. So now my application code itself has no knowledge of authentication and authorization. It will just automatically acquire a token for me underneath the covers. So now let's run the server. Actually, let's go to Azure. This is the client here, yes. And I can execute this, try it out. And this one doesn't have any authentication as part of it, like I would be using Auth0 or something, but the important part here is that it's using its own managed identity to then make those requests and acquire the tokens, and we can see that it all works successfully. Like it was able to call that server and acquire the token appropriately based on it being a managed identity. But the nice thing about managed identities is it's still OAuth client credentials underneath the covers. Like there's no magic there, except that client secret you never have to worry about ever again. I don't have to worry about managing that secret, keeping it safe, blah, blah, blah. It's just like, it's all managed for me behind the scenes with Azure managed identities. And so we don't have to worry about all that extra configuration and whatnot as part of our system. So I know it's like there's a lot of stuff we had to consider as part of this, like all the different OAuth flows. I know we've managed basically just to do client credentials for our specific scenario, but it is one of those things that every time I'm presented with authentication and authorization, I have to go back to sort of first principles and say, here are my different options. What are the ones that are appropriate for my specific application and system? So you will, like in your own systems, you will need to do those sort of things, like figure out what makes the most sense for your specific application. So I made no guarantees about the demystification. So if you have questions afterwards, I'll be happy to answer those after this. Otherwise, this specific code you can download. You'll have to change like your Pulumi stuff to run against your specific junk, but you can go download that code here at the Azure AD example. And this presentation, the slides can be found on my presentations repo up there. And I blogged exhaustively about this topic as well, so you can go check out the blog for all the details too. Otherwise, thank you all very much for coming. I appreciate everyone's time here. And yeah, y'all have a great weekend because we're done, right? All right. Thanks, everyone.